The circuit for this demonstration emulates task A from the lab with the flashing LED, this time being toggled by the press of a button. The RPi Pico outputs 3.3 volts and ground, which are wired to their respective side rails on the breadboard. Voltage is provided to the LED, which is wired in series with the resistor to make sure that we avoid burning out the LED with a voltage outside of its specifications. We also have a button that is wired to the circuit, which is mapped to pin 21 on the Pico, which is the GP16 pin. The button also has a pull-down resistor wired to it, which is then wired to ground. This ensures that no voltage gets caught in the wires instead of dropping to 0 volts once the button is released by essentially pulling, quote-unquote, any remaining voltage out of the circuit. Not utilizing this resistor might prevent the circuit from working properly. So for the code that actually runs this program, we want to first import some of the default libraries for machine and time, and then set the output and input pins for the Pico. So the output that we're providing the LED with from the Pico is being set to the first pin, which is pin 0, and then the button is being set to pin 16, which is the GPIO pin 16 that I mentioned before for the input, which is where the Pico is going to look to read the input from the button. Then we just run a basic while loop, which is just going to check whether the LED is on with the if button value statement and the else. So the button value statement will return true when the button is on, and if it's on, it'll then run these lines, which just turns on the LED with value 1, prints that it's on to the shell, and then pauses the code for about half a second, and then just repeats the same thing except setting a value of 0 and printing off to turn the LED off, and then it'll just repeat this whole loop, which is regulated by this time.sleep function here. And if the button is off with the else statement, it'll just set the LED to 0 and not have the LED turn on.